My name is Steve Herbener, and I'm a software engineer that works on the Jedi core team, and I work on the Yoda subsystem within Jedi, which is the piece that handles observation data. And we'll get some more details about that later in the afternoon. But for now, I want to talk about the system configuration, which pertains to the YAML files that we use in the system. So we have a pretty extensive and flexible configuration system, and the whole goal behind this is to try to get it so that you don't have to write customized code when setting up and running DA flows in the system. Instead, you just go in and you configure by modifying YAML files. And YAML is a human-friendly data serialization, I guess, is a way to describe it. It's a way to put keyword pairs together and use that for configuration specifications. So go on to an example here. So I've got a few examples here to kind of get you introduced to the syntax. Some notes here, whenever you see a dash, a hyphen, that's like an element that's within a list. That's what that's denoting. And a colon separates a key and a value in a key value pair fashion. And one of the nice features about YAML is that you can put comments in it so you can kind of describe what's going on. And that's denoted by a pound sign. So in this first example here, in the upper left, this is just demonstrating a list. So there's a dash in front of each element of the list. So it's got these baseball players' names here. And then in the second one here, we have just a series of key value pairs. So when you parse this YAML file, you'll get a keyword called HR. And in this first example, and the value that's associated with that is a 65. And so forth. And on the lower left here, we have key value pairs where the values are lists. So if you were to parse this and get this American keyword, what you would return back would be like a vector of strings, where the first element is Boston Red Sox and the second element is Detroit Tigers and so forth. And then in this last example, this thing, okay. This is a list where the elements are a set of key value pairs. So this is part of a larger list. There's two elements described here. And when you access those elements, you'll have a set of keywords. You can say .name and get Mark McGuire, or if you do the second element and you access .name, you'll get Sammy Sosa. So this is a way you can group a set of key value pairs as elements in a list, and that's a very handy way to use that. So I'm going to use a 3D envar example to kind of walk through the configuration that's used in the Jedi system. So it'll give you kind of a feel of a typical things that you have to configure and set up, and I'm going to kind of stay at a high level. There's quite a bit more detail involved in tweaking things, but I'm going to kind of show the basic functionality and how you set things up. So to start here, this is a variational technique. So we have a cost function, and it has a model side denoted by the JB, and it has an observation side denoted by the JO, and these terms in the cost function. And so, whoops, up here at the step one where we run bump, to generate a B matrix, we have these two pieces, a static and an ensemble piece, that go into the creation of a B matrix. So the basic steps that you go through in 3D and var is first you run bump to generate a B matrix, then you run the 3D var, which is utilizing this B matrix on the model side. And then you run an increment and get diagnostics. And we'll see this later in the week when we start talking about the models and do the activities related to those. So the first application is the thing that creates the B matrix. And as was described in the lecture before, most of the applications in Jedi are set up where you have a binary file that's created by the build process. The first argument that you give to this binary file is a YAML file that controls all the activity that's going on in the application. And then you have this optional second argument, which is a log file to dump out all the results. So in this case, we are going to do a localization creation of that B localization matrix. And this is a snippet of the YAML file for controlling that, and it has some ellipses here to just denote that there's more details in here, but I've cut those out so that you can kind of see the major pieces here. So first of all, you're specifying a resolution, a geometric, like a grid resolution from the model, and that's in this namelist file that comes with the model. And then you are specifying the increment variables. This is a temperature and surface pressure in this case. And then you tell it to perform the localization function. So there's a section with bump and you give these parameters to it to drive that. And then you run the application. So this is roughly, this section here is controlling how bump works and creates the B matrix. So that's the first step in the process. Then the second step was to run the 3D and var. So that uses this Jedi var.x application, and you give it a YAML file to control the E and var, and then a log file to record the results. So in this case, you have this cost function section, and when you make an indentation in the YAML, you get a nesting of things. So this cost type here is describing a 3D var algorithm that's going to be used, and you would access this by saying cost function dot cost type, and then you read that and you get the value out of that, and it's a 3D var. So that's what the nesting does. You can group things together. So you're specifying 3D var and the variables that are involved. So you've got the winds and the temperature, pressure, moisture, and so forth. And here you remember in the cost function that I was showing, there's a model side denoted JB, and then there's an observation side denoted JO. So these are specs here for the JB side. You're defining that you're going to do a background error with a covariance model, and it's using this ensemble method that was back on the prior slide, where there's two pieces to the B matrix assembly. And then you have all these different members that you put in to create that. And then here you describe the JO side, or the OBS component. So you're listing out the observations. And here in this example, you can see aircraft in an AMSUA on a NOAA 19 satellite description being put in here. So to zoom in a little bit on these observations, we'll talk about this a little more detail. You can define an OBS operator that drives so you're setting up the pieces that do the H of X calculations in this observations section. And you name the OBS space. So this is AMSUA NOAA 19 satellite. You're going to use the CRTM, the Community Radiative Transfer Model, to simulate the observations. You're going to use a diagonal covariance model to model the errors. And then you run these different filters like a bounds check, a background check, and a domain check to process the OBS data before you do or as you do the simulation. And then at the final step was to run some more details about the 3D ENVAR. So at the end of the run, you're gonna tell it at the final step to write out some diagnostics, and you want to put departures out into so that you can make a plot of these eventually, and these will appear in an output file. So this is the O minus analysis specification that's here. And then you're specifying for the variational minimization, you're specifying an algorithm to use. There's quite a few algorithms that you can choose from in the system. And you're also specifying the iteration control. So every, this is, you can see the list marker here, the element, the dash here. So if you only see one of these dash elements here, you're defining one outer loop iteration with 25 inner loop iterations, and then different parameters for that inner loop iteration. If you wanted to put more outer loops, then you would put another dash and then say in or 25 again, and just keep repeating this for each of the outer loops. So then at the end, we want to create an increment so that we can run some diagnostics on this increment. The increment isn't particularly part of the whole DA looping process, but it's a handy thing to dump out every once in a while for diagnostic purposes. So that comes with its own YAML file, and you're specifying grid resolutions for this increment piece. And then you're stating which variables that you want to have increments for so that you can make plots of these later on. And then an output file. So you want this to be gridded on lat/lon grid and produced into that file and that path that's specified there. So along with the actual configuration and editing configuration files, I also wanted to kind of show how the Jedi system processes these files and makes sense out of them. So ECKit is one of the pieces that comes from ECMWF that we use in our system. It's one of the dependencies that was noted this morning. And it has a configuration class in it that's used to parse these files. So when you construct an object of the configuration class, you give it a file name and it parses the YAML that's in that file and builds a configuration object in memory. And then this configuration object has methods to read the key value pairs. And there's a link here in the slides that can take you to read the doc's information about this, giving a little more explanation. And then FCKit, another ECMWF package, provides a Fortran interface to this ECKit API. So it goes through the ECKit API, which is a C++ interface, and just allows Fortran to directly make those calls to the parsing and the configuration objects. And we've recently introduced a new OOPS parameter class, which provides object storage and management of the parameter specifications. So what this parameter class adds to the system is the ability to eventually describe a schema to this parameter class of what the expected keywords are to be finding in each of the YAML files, along with like valid ranges for the data and things like that. So it can do more checking on the YAML specification and catch errors up front instead of letting the system run and you have this difficult debug process to try to figure out what's wrong with the YAML file. And that's all work that's under development right now. So to give an example of this YAML API that ECKit provides, here we have a case with nested keywords. So every time there's an indentation, there's a nesting, and you separate the nestings by a dot operator. So in this example here, name and simulated variables and generate, these three things are nested one level down from the ob space, which is up here. And then the keywords like random and obs errors are nested two levels down from the top. So then if you wanted to access this nobs value right here, then you would use a key that says obspace.generate.random.nobs. So it's obspace.generate.random.nobs, and then it would return the value 10 with that path that you give it. So ECKit provides these access routines to read these values out of the configuration. So when you have an integer value, you have this get int, and you have this string that you pass it, and the string is that path that was given here. Whoops. Obs space generate random nobs. You pass it that path, and then it returns the 10 for a value. And this is something that you put in your code to read that piece of information out of the file. You can also do things like vectors. So this is a get float vector, and you give it obspace.generate.obs errors, and you would get this vector back that has a value of 1 in the first element, and a value of 2 in the second element. So one more thing that I wanted to mention here is this feature isn't released yet, but we have this major evolutionary piece that we're putting into the system now that manages all these DA runs on a workflow level. This is a project called EWOC, and it's under development, and it's operating on a lot of good things right now, but it's just not released yet. And one of what this does, the EWOC does, is it kind of puts everything up at a higher level, and it says, I want to run like a 3D envar run, and I want to use this monthly cycle at this date and time and everything, and you specify things kind of at that manner, and it goes in and figures out how to put all these details and configurations and knobs and things in the YAML that exists right now in the system. Makes everything a lot simpler for a user to set up and operate. So there's a lot of details right now that people have to take care of in the YAML files, but very soon when this EWOC functionality gets released, it'll be a lot easier to configure the system and run. But for the purposes of the activities and things this week, we're still at this level of kind of higher detail, like the examples that I've been showing in this talk. So I just wanted to mention that this is coming along, and it's going to help help people manage all the details of configuring the system and putting things together.